All right, let's start a brand new screen here. Maybe I should restart the kernel to delete away the old variables. Okay, let's do a simple copy and paste. So here, remember we were talking about manifest type literals. So when you type out the value, the data value like 3.5, we know the data type is float. It cannot be int because there's a dot there. It's clearly visible. It's type manifesting. It's showing its data type by looking at it. So it's a bit like animals. You know they're dangerous if they're highly colorful. They have highly colorful skins like bright red and bright purple, right? So better don't touch me. I'm highly threatening to you if you try to eat me. So here, manifest types are a bit like that. It's indicating it's not the threat level, but the data type level. Now here, this pair of square brackets, they are what is allowing this to be a manifest type list. Why? Because once you see a square bracket, definitely we are creating a list. Okay. Another way to create a list is to explicitly convert something into a list. Now, of course, you cannot convert anything to a list or everything into a list. A string can be converted into a list. A range generator can be converted into a list by running the engine that generates from 11, 12, 13, 11 plus 10. So 11, 21, 31 until 91, and 101 will not be generated because we'll stop just before 100. So that will be another way to quickly generate systematically stepping, kind of a sequence of numbers, and in a very compact way. So we don't really call this list function a manifest type because we're actually calling a function, and this list could have been renamed as nobody. So we call nobody range, and then that can produce a list. So it's not really manifest in that sense. But the square bracket operator, it is manifest type operator in the sense that when we list out the sequence of data values in between the square brackets, they will become the content of a new list that will be created by the square brackets. Okay. And let's just run it like this. Yeah. Okay, so what is the type of P? We expect to see a list, and that's exactly what we see. And how do we create empty list? Like this. All right, I tend to personally just type a space to emphasize that it's a pair of square brackets. But if you like, you can just put open, close square brackets, and it's a list. All right, it's an empty list. So we can just create the structure and not have anything inside. That's very good notion to know. All right, how can we think about it in real life? Think of a list as a kind of a plastic bag where you have to enforce the sequence of putting things in. So you first put an apple, then an orange, then a pear. So this plastic bag will preserve this sequence of apple, orange, pear, and will not jumble them out. So when you take it out, you say, give me the second item, it will be orange. It will not be apple or pear. So that will be like that. How do we extract items out from the list? Very simple. Everything starts with 0 based. So the first item is index position 0. All right. And the last item is 0, 1, 2, 3, 4, 5, 6. All right. So we can say P of 6. That's the last item. Or Python allows the notion of -1 is the last character or last data or the last entity in the list. So we can do that, right? And we can also do slicing, get a range of things. So for example, let's look at P again. If we want the second data to the fourth data inclusive, then all we need to do is to say P of, remember the second data is index position 1. So index position 1, 2, and 3, right? But we don't type 3, we type 4 because the ending position is by convention, by Python convention, not included. Okay. Now, suppose we want to take the first data and jump, all right, We want 6, 2, 1, and 2. It's very systematic. There is no exception. That means there's no special treatment. We just always plus 2 instead of plus 1. Then we simply say, we take starting from 0, and starting from 0 can always just skip. You can always not say it. So starting from the beginning, ending at the 7th position, because this is the ending position is 6, but we also include that. All right, let's just include everything first. So starting from 0, ending at 7, jump by a step of 2 instead of 1. So now we'll get 6, then add 2. So 0 plus 1 plus 2. So 0, 2, 4, and 6. And that is also accessed because 7 is larger than 6. If, however, we put 6, you notice that the last 2 here will be skipped because the last ending index is always not included. Now, in addition to this slicing, right? So you can do various very interesting slicing of extracting data from the list. Python also supports this additional convenience. I won't say convention, but convenience of if you're talking about 0, you can ignore it. If you're talking about the last thing, including the last thing, that means one position beyond, you can ignore it. All right. So here we need to say ignore, and step of 2, and we get back exactly the same thing. So this, once you see it often enough, you're like, that's great. Of course it should be. I shouldn't need to count and then find out what's the last position, right? And so on. So that's that. Okay. This is often the point where I ask, is there any question? But I think, of course, you are just listening in. But of course, feel free to type in comments or parts where you find very interesting, and then I know what to do next time by, maybe elaborating more or showing more applications or examples about that. Or you can tell me how can we do certain tasks, right, by using these topics that we have discussed, and I can see what I can do about those questions of yours. So then we talk about tuple, and well, I lost my data, so let me just see it again. We have Q, right? Q is a systematically generated list, and it's interesting that we are using range here because range on its own doesn't produce the list, it produces an engine. It's sort of like, range, can you generate the numbers starting at 11 until and not including 100, jump by steps of 10 every time. Range says, okay, fine, I give you this factory, this engine. Don't run it yet. If you don't run it yet, it's just an engine. It's well contained. It's not taking up a lot of space. It's not even running. So no numbers are churned out. Then how do we run it? You can run it by putting it in a for loop. It starts running one by one. You can run it to the end and force all the numbers to come out by putting it inside a list like this. All right. You can also put it around a tuple and these two, or a set even. That will force the engine to run. Now, why this two-step approach is because it makes a lot of computer science sense to just give you a generator like this. Because what happens if you really intend to generate lots and lots of data, then it comes back right away. All right. So long as you don't run the engine, it's just a small engine, and you can just, basically say, I'm going to have a sequence that's like 11, 21, all the way to, I don't know, 10 gazillion. But don't give me the numbers now. I'm going to run it slowly, like in a for next loop, or I am going to run later, not now. Okay, so that's the neat part of it. So long as you don't just force a list around it, it's going to be benign. But the moment you type list of range of this thing, it will explode. It will sort of hang for a long time until the numbers are generated. Okay, tuple. Let's look at our tuple. We have a T here, which is no big deal. We try to put in floating points, mixed with integer, mixed with string. We can even put in a true, a boolean, false, no problem. And it looks like a list. First of all, how do we explicitly create a manifest types tuple that's created by brackets? Okay, now be careful. We really have a lot of uses of brackets because we do that for function call, we do that for function definition, we do that in overwriting the precedence in calculations, like 5 plus 2, I want to do first before you times 3, right? So how can Python make sense of it? It can. It can, so long as you are clear. So long as we are clear here, we are not writing some sort of a arithmetic operation, with plus and divide and times, then Python knows that you are doing tuple creation here. So the presence of brackets, they are manifest type tuple, right? Now, earlier on, we were trying to say that list is mutable, and the difference between list and tuple, everything is the same except tuples cannot be changed. The internals, the contents of the tuple cannot be changed. So we have P and we have key here. So whereas we can say the second item of P, I don't want it to be 7, I want to change it to 9. And what is P now? That's 9. Can you see that? But not so for tuple. I want to change the second item from 6.3, I typed wrongly, I want to change to 3.6. I will get an error from Python scolding me for trying to change something that is not meant to be changed. Okay, so it says it's a type error. Actually, it could have been any error because maybe there's no type error. I don't want it to be changed. That's why I call it a tuple, right? But someone else, maybe it's my future me, unknowingly tried to change it. And so it's a violation of the read-only access issue. So even though Python calls it type error, it's not meant to say that you should change it to a list to make it changeable. So just think through first. And of course, just to illustrate the equivalence, we can also create a tuple by running the function called tuple with a generator that churns out all the numbers and then wraps around them with a tuple bracket, and that's okay. Okay, notice that this list open close bracket and the tuple open close bracket, they are not trying to say I want a list and a tuple inside. Not like that, because this bracket here, sometimes called parenthesis, this pair of brackets, they are basically calling function called list that is built into Python. All right, so it's actually a function call rather than a explicit manifest type tuple. So same thing here, we are calling the function tuple. Just like we could have renamed the tuple to Tupperware or something else, or metal box and bracket, and that's fine because that's still a function call. Yeah, so don't confuse them. This standalone parentheses, they are the manifest type tuple, but name followed by brackets, they are function calls, very different.